Right. With a double acting cylinder, you'll have a 5-2 valve. I've drawn a 5-2 pilot here. The secret to the credit one is just to remember, if the signal comes in at this side, it comes out at that side. So those two pipes are kind of linked. Okay? If the signal comes in here, it comes out there. If the signal comes in this side, it goes out in that pipe. Once you remember that, the rest of it is just looking through the rest of the circuit and working out when you're getting a signal there. Okay? There might be a plunger valve up here. Okay, so when that goes positive, it hits the valve. So then it needs to go negative. So the signal would need to come down. Yeah, okay. Now, we might want to control the speed the piston moves at. We use a unidirectional restrictor. There's a wee arrowhead there. That arrowhead shows the direction the air travels slowly. The air will go fast that way. It's a unidirectional, which means it's only one direction the air goes slower. So we can use this to slow the piston down. If I put one here, the wee arrow always points away from the cylinder. That one there, so that means the air goes slowly that way, slowly down. That goes slow, positive, positive slowly. If I put it here, it goes negative slowly. There's air inside the cylinder. Air goes up in here to push out the cylinder, and this air has to go out. It's called exhaust air, and it's squeezed through the restrictor and then out the exhaust. It's always the exhaust air you restrict. The reason for that is we don't restrict the exhaust air. The piston, when it comes out, might judder, and it might not be able to lift whatever it's supposed to lift. We can use a unidirectional restrictor with a reservoir. If the signal goes in here, this combination of components delays it. Okay? That slows down the speed the air is going at, and the reservoir drops the pressure. Okay, so it takes a while for the pressure to build back up. So that has the effect of delaying the signal, those two components together. Okay. We might have to calculate the forces in the cylinder. If it's outstroking, there's a bigger area than if it's instroking. Okay. On the outstroke, the air is going to push on that whole circle there. When it's instroking, it's only going to push in a sort of polo shape, okay? Because the piston rod is in the way. The air can only push in that way. In the outstroke, it's simpler. In the general paper, you might have to find the area, you might not. Okay, so the formula is pi d squared over 4. The question will give you the d. It might just give you the area and you don't need to do that step. Then you have to do the force is the pressure times the area. The question will give you the pressure. Okay. If it asks you to find the pressure, if you change the formula, the pressure will be the force divided by the area. In the credit one, the only difference is you have to calculate that area. Okay, so you have to do two calculations. Calculate the area as if for the outstroke at the back there, so that's pi that diameter squared. And then once you've got the answer for that, subtract the area of the rod. Okay? And then that'll give you like the area of the polo. And then the force is the pressure times the area, just the same as in the other one. Okay? Thank you.